The first problem in section 1.5.1 asks us to find the critical points and critical values of the following function. F of x equals 1/3 x to the 1/3 power minus x. Now, the first step in finding the critical points is finding where does the derivative equal 0, which is the definition of a critical point. So let's first find the derivative. Now, use the power rule to multiply to figure out the derivative of the first term. So we have 1/3 times 1/3 x to the 1/3 minus 1, or negative 2/3. And the second term, we just have minus 1. So if we simplify this, we get 1/9. Let's write this 1/9, and we'll move the x to the negative 2/3 into the denominator. So it becomes 1/9 x to the 2/3 minus 1. Now we want to set this equal to 0. So we have f prime of x equals 0. This means that 1/9x to the 2/3 minus 1 is equal to 0. So now we just solve for x and figure out what values does this hold for. So move the 1 to the other side and multiply by 9x to the 2/3, and we get 9x to the 2/3 equal to 1. Actually, we might want to keep that 9 in the denominator over here. And now we raise this to the power 3/2. So we have x to the 2/3. So 3/2 power is 1/9 to the 3/2 power. And this gives us x equals 1/9 to the 3/2 power, which is 1 over the square root of 9 to the 3rd power, or 1/3 to the 3rd power, which is 1/27. So this is the critical point, meaning that f prime of 1/27 will equal 0. Now, next step is find out what is the critical value, meaning what's the value that f takes on at this point. So to do that, we simply plug in 1/27 into our original function f, which is 1/3 times 1/27 to the 2/3 power, or excuse me, to the 1/3 power, minus 1/27. This is equal to 1/3, and this will be 1/27 to the cube root of 27, which is just 3, minus 1/27. This will be 1/9 minus 1/27. We find a common denominator, 27. We end up with 3/27 minus 1/27, or 2/27.